Welcome back to the WAF Live video series presented by WAF Logic and the WAF guy, this guy. Hopefully our last video was educational and insightful. That was our intent. And as we said, this video and future ones will be a lot more hands-on as we delve deeper down the rabbit hole of WAF life, taking a look at the more intricate advanced WAF techniques, tactics, features, and a lot more. Essentially the really cool, fun stuff and why I love my WAF life job. So this is part 1 of 2 for chapter 2, which is entitled Logging and All Your Database Belong to Us. We are going to show a database takeover where a database was completely exfiltrated, where it was entirely dumped. We're going to show you from start to finish of how that all worked out in a 2-part series for that matter. But moving forward here, when I build out a WAF infrastructure in any environment or any security system infrastructure for that matter, step 1 is bring the system online so it has some functionality and, well, it's there. Step 2 is configure logs. So naturally, it just makes sense for chapter 2 of the WAF Life video series to cover logging. Just makes sense. So each WAF has their own uniquely varying logging abilities, options, and field value formats, just like every other system out there. They're all unique in their own ways. And you really have to give credit to your SIM parsing team for what they deal with, because, wow, the diversity of log styles defines the definition of the word diversity. And to make it even more complicated, sometimes old versus new features on the same product or platform, however you want to call it, they have different logging formats with different fields and values for each feature. So you'd have to differentiate parsing for those as well. Just, add to the complications. Why not? Now, that's just the format to be ingested and parsed. As for the delivery method, it's a little simpler, but still it varies. Now, shortly here today, I'm going to go ahead and show you my ASM WAF supermassive Splunk query, which tends to shock folks when they first see it, just due to the sheer size. It's entertaining. 21,772 characters or 197 unique operations in length, just depending on however you want to look at it. But the detail is what truly matters, and it's absolutely exceptional. This format has been called the gold standard for WAF logs by some Fortune 100 companies for that matter, and it's still adopted and used today. So, all right, enough with this video face. Let's go ahead and see some actual action. Today we're here on the F5 at WAF Logic since, well, we own it and we won't be violating any NDAs. Plus, if we break anything, it's not a customer's problem, it's our own problem, but we're pretty good at what we do anyway, so we should be fine. We also have a damn vulnerable web application, or DVWA for short, stood up behind our F5 to be our guinea pig for our logging demonstration as well. After all, it does help to show real events if we want to go ahead and show, the real value of making the most out of your WAF logs. So let's go ahead and take a look at the quoted gold standard logging profile for F5ASM that we at WAF Logic use for our clients and our own WAFs for that matter as well. While this is F5ASM or Advanced WAF, as F5 calls it now, the overall concepts we'll explain and demonstrate today will translate to any WAF security solution. So looking at the log profile, one of the key things that we have here to start out with to mention is response logging. Now, you don't want to log every response possible, but any potential illegal violation, particularly with response-based signatures, you do want to log those. Hence why you would want to have this selected. Now, not all WAFs do offer this feature, but when available, definitely it's very worthwhile to select. Now, one of the other key important things that we're going to mention here is the protocol. UDP is the most common method for sending syslogs for most network and server systems. However, it's not the best for WAF logs. TCP-based delivery method, what we have selected, is your best option with WAF logs to ensure delivery, especially considering the size of WAF logs. just because the likeliness of them being fragmented is pretty high. So why TCP? Well, TCP can handle a fragmented payload up to 64K and guarantee reception, whereas UDP, despite handling up to 64K, does not guarantee reception, and it just doesn't handle fragmentation reliably because there's no guaranteed validation or insurance. It's like having, versus not having a tracking number and insurance for a package that you send. You wouldn't be very pleased if the most critical package you needed, like a log of a breach in this case, was lost in transit with no insurance and never to be recovered again. Also, with UDP, only 4 out of 5 of those fragments were received, then the package is useless. There's no recovery. With TCP and the tracking number with insurance, the server will re-request that missing fragment and the damaged package essentially gets reimbursed, and then you have the whole package finally delivered. Now, as we mentioned, 64K, that's where maximum entry length here, that's maximum size of log that you can send. 64K being the max, might as well use the max because 64K means more potential room versus say 1 or 2K for more viable information and evidence about the event. I mean, really, the juicy WAF events tend to be packed full of all sorts of insightful details, so the more the merrier. Essentially, knowledge is absolute power here, and you want to ensure you have the most potential reliable evidence possible. So always use TCP when possible. So here's where we get into the gold standard of WAF logs. The key, if you will, is to use a comma separated value and not key value pairs ever. Like we have here, comma separated value, we're not using key value pairs. Essentially, you want to log just the data and not waste the space with the names of the fields with every single log, since you have the map already, which is down here, the selected fields which we're going to log. So since you already have it, and ideally you'd be using a SIM, a security incident and event management solution, such as, Splunk in my case here and many others, to parse these using the map as is. So again, there's no need to waste the log space on information you already know, like having these elements within the logs. You have the map right here. Now, for the CSV part, the comma separated value, you need a very specific delimiter or a very special delimiter that has to be multi-character. You can't use a single character delimiter with WAF logs just because every character possible to type and more are used to some extent in the web application world. Now, double quotes as a text qualifier helps, but it's not uncommon to see that as a standard query for a web application as well. So let's go ahead and take a look at an example real quick. Over here, this is your typical comma separated value with double quotes as your text qualifier. So looks parsable, very consistent, but then you have an application such as, potentially this as an example, where you have your URL and then you have the query, but the query has comma separated values within itself. And because it's such a de facto standard comma separated value, in this case, that's what they use, and this will break your parsing. So thus, you'd never be able to see this log. And if it's something critical, well, unfortunately, again, you never would have saw it unless you dig for logs that you weren't parsing to begin with. And most just assume that they were parsing it correctly, so they never would look. So with that said, that's where the tilde comma tilde, or we'll just call it the bird delimiter, just because of how it looks, kind of like a seagull, is a delimiter I came up with and has not failed me in over a decade on parsing WAF logs yet, just due to the consistency of the log format and the accuracy of the regular expression match for parsing. So the bird delimiter, as we're going to call it, does not exist in any programming or query, etc. language I've seen either, for that matter. The keys are hard to press in sequence as is due to their location on a keyboard, so naturally it just makes sense that they're not used. And to help drive that point home a bit, here's a map of examples of how to write hello world in a variety of coding languages. And as we can see here, there's nothing really that conforms or is even relative to my bird delimiter. The only one that kind of comes close maybe is Fortran down here, but with the asterisk versus tildes, just completely not relevant. Looks a little fun. Um, so just nothing comes close, and that's the reason why I'm able to say it's so effective. Now, here we have the fields which are sent in each log, and that's this list over here. And then over here, we have like over half that are not selected because they're just simply not necessary. Many of these are network centric, such as like source and destination ports. They're just fields that are irrelevant when it comes to a standard everyday security log. Those are elements that we can reference in the configuration as needed, since it'll be likely a one-off situation as is, thus there's no need to waste the storage space in the logs. The key is to select all the fields that will provide your organization the most value and exclude the ones that won't. Briefly, we'll go ahead and show off the list that we have for, we consider pretty much the de facto standard. This is the basics of everything that you need for your logging fields. And as you see, we've got 32, but the other list, there's a significant amount of others that we don't use. Now, there's some that are actually very useful, but only if they're relevant, like because we don't have IP intelligence, the service subscribed, it would be useful if we did, and then we would use the log element and just adjust our parser as necessary. But at the moment we don't, so we don't have it in there, but easy add if need be. So let's take a look at a log event using our gold standard log format and the ASM supermassive Splunk query, which would be this massive thing. And as you can see, well, that's quite massive. Wasn't joking. So the log that we're going to look at here is very special because this is when a server exposed its database name, and in the end led to the database being exfiltrated. In other words, no bueno. So here's the overall data and everything that was extracted, and in a much more prettier format. But as we were talking about the delimiter, the bird delimiter, here we can see the raw log of what's actually sent. And you can see it's just pure value, pure data. There's no key names here. So none of that space is wasted here. And we can see it's a significant amount of data, over 6,000 characters or 6,000 bytes. And because the extraction that we have done with our SIM, or Splunk in this case, that's how all these fields are created. And I mean, that's how we're able to leverage, and pivot on different queries. But here we can see the individual signature IDs and etc. So we'll get into the bigger picture of the cost savings and all that money stuff in part 2 when it comes to this log format. But for now, let's go ahead and look at the useful information from our massive log query here, the Splunk massive query, this big old thing. So coming down to the individual events, all the fields to the left of metachar, which would be all these, are your standard extractions that come through with the regular expression magic with the base logs. Now, everything to the right of metachar, including metachar for that matter, they all come from this field over here, which is violation details. And as you can see, there's a significant amount of information here. And I take all that information with all that magic up here, and I extract it out into the other fields in which you see here. As we move, on down the line, all the way back over to our metachar, buffers included. Now, VD-SIGs, some of the information, actually all the signature information does come from there. It's a little more comprehensive. Doesn't validate explaining right now on why, but nonetheless, that's where I pull it from. And VD stands for violation details, not what you may think it means. I didn't really get the pun until after I had created the query, and whatever, it stuck. And it's probably more accurate than those tests anyways. But moving on. Every individual buffer item that we have here came from, again, the violation details, and it's relative one-to-one for each individual signature that is detected over here. Now, you may look at this like, well, why would any WAF block just a random string of alphanumeric characters? That just doesn't make sense. Well, it actually does, and we'll show you the reason why. Over here, we're just going to go ahead and base64 decode this because, as you might have surmised now, this is a base64 encoded string. And we could see kind of off the cuff, yeah, we got some potential SQL action here. We got an OR statement and a function or possibly table. So let's go back over to our query, and let's just take another random string out of example here and decode that. And there we are again, the table or function and concat and the select statement. And there's our 1 equals 1 or 9014 equals 9014. True statement still. So nonetheless, yeah, that's a SQL injection. Now, we could decode the rest, but nonetheless, that's not really important. We're going to just kind of walk down the line because already we can infer that we do have something bad happening here. And also, for that matter, our metachar, meta character, we have a certain set of meta characters that are allowed globally, and the rest aren't. And typically special characters, and in this case, it triggered. So just further giving insight, because the amount of volume of buffers and amount of volumes of signatures we have triggered, plus being SQL injection, this implies we probably have something pretty bad going on here. Now, Splunk and most SIMs are able to decode by base64, but only when there's a single value per field. In this case, for the buffer, as we saw, there's multiple values. And that's why I can't decode it. But with the parameter name, we can decode it, and because it's a single value per one field, and hence it turned out to be ID. And that is the parameter that was attacked. Now, in the sense for the value of the parameter, we have this string, base64 again, but decoded as denoted by, basically value underscore dec or decode, mirror of this. And we could see the statement that was originally passed, or at least what was detected, and some of the before and after. So that's what was called out for the meta character, the single tick. And as we move on, back to the violation details, that's again where all that information was extracted from. Now here we have the request, and we can see the request really wasn't that big. This was essentially the attack right here, all the way up until this point. And that we have all that other information that was extracted or interpreted from this event. Now, granted, it's a lot more information than what we see here, but the key is it just gives all the validity and all the different angles of evidence to prove that this was a very malicious activity, or likely. Now, here's the icing on the cake, if you will. This is where everything went downhill. In this case, we have the server response log, and as we said earlier, not every WAF technology offers the ability to log the response. Now, in this case, we do have the ability, and we did, and we could see that we had a SQL error, and it was an exception error, and no big deal, exception error, but in this case, it mentioned our database name, DVWA, and just because the table doesn't exist. So even though it's not necessarily a bad error in that case, it exposed the information for the database name, which gave our attacker the information that they needed later to exfiltrate our entire database. Now, fortunately, in our case, this is a demo scenario. We did use real attacks leveraging SQL map and basically technically a live database. And essentially, this is really how it could happen. And because we had our WAF in a transparent mode, all these attacks were able to proceed. Hence why we have all the logs of everything occurring, but no action being taken. And that's what allows us to be able to demonstrate what could have occurred. Now, in a blocking mode, just simply because of everything that was detected, we can guarantee that this would have been blocked, all of this. But nonetheless, for demonstration purposes, we could at least say that no companies or databases were harmed in the making of this video. So that's it for today. Next time, in part 2 of Logging and All Your Database Belong to Us chapter, we'll be digging deeper into the database dump we briefly just looked at today. We have the entire series of events from start to exfiltration captured in our logs. We'll go ahead and include all the resource materials, including the ASM WAF supermassive Splunk query, the full set of WAF logs showing all the attackers' requests and server responses that led up to the database, being dumped to the attacker. And we'll also include the SQL map logs and the command. We'll also talk about something every company loves to talk about, which is saving money. And we'll be using our security logs to achieve this. So for now, stay safe, stay secure, and thank you for joining WAF Logic and the WAF Guy, and we'll see you next time. Have a great day.